Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week on the podcast, I spoke with Gerard Kruisheer, the CTO and co-founder of Captain AI, a company based in the Netherlands working on autonomous shipping out of the busy Rotterdam port. We discussed the unique problems that come with building autonomous vehicles, the extent to which the latest and greatest research informs their work, their production stack, and how they handle deployment for their particular setup. As always, please let us know if you have guests you'd like me to speak to by sending a message to us on Slack or by emailing podcast@zenml.io.
So my background is actually in marine science. I went to the University of Hawaii, and I love the ocean. I love the nature, and before I went there, I was more involved with I was thinking I was going to do some genetics or something like that. I wanted to get into something that's cutting edge and something new, but I didn't want to be in the lab all day. So I really I kind of got this passion for the waters and the seas. Kind of throughout my whole life, I've been somehow involved with beaches, diving, snorkeling, oceans. So I already had this love for the oceans. And then I also had, together with that love for science and technology, my whole life I've been taking things apart, trying to build things. I always just had a curiosity. I enjoyed putting things together to solve problems. And so as I started going through school, you're kind of trying to figure out what you're doing with your life and what you want to do. I kind of merged all the things that I liked together and started pursuing things like with underwater robotics. Really got into manufacturing at that time. I think, developing became more accessible with 3D printers and laser cutters and all of these things. And I started loving these machines, started loving how easily you can make things. And that, so I started building ROVs in university. And then after that, I graduated, worked a bit more in product development at Origin Base. Was also kind of like a startup. We wanted to help people prototype and develop. And so I had a lot of experience building projects, essentially for people. And so that gives you that exercise of here is a goal, here is a product that you have to develop, and usually it's not something that you can just buy. It would be custom. And then you have to set out a timeline, and iterating through that cycle, I think, made me really kind of understand how projects should be put together. And so at one point, I just decided after another job, I just decided I'm going to start my own company. I've done this for other people. Why can't I just do this for myself? And so I started doing this, building this underwater vehicle, which was designed for scuba divers, which you could use to map the reefs using cameras, because sonar technology is really expensive. And if the waters are clear, you can use 2 cameras. You can do, stereoscopic. You can just get depth images out of 2 cameras and get an idea of what the 3D environment would look like. And in my mind, I'm like, yeah, we could kind of create a backup of the reefs, what that would look like, create a 3D model, and then over the years, you can kind of see how the reefs change. I really I had this idea of really being a lot more precise in quantitative analysis in marine science, because I felt like that was lacking. I never really thought of the financial impact on those things. So yeah, once you have to address a business case and a need, the game changes a bit. And at that time, I was in the UAE, and I had found someone who was willing to invest in this idea. It gave me a little bit of capital, a little bit of resources, and then I really started learning what it takes to start a company. I was doing all of this by myself. I was naive enough to think I could build, design, program, deploy, and sell all of this by myself. Quickly learned that is it's unrealistic, and so when I came to the Netherlands, I was also thinking of continuing and pursuing. I kind of came to the Netherlands as a fallback plan because I'm actually a Dutch citizen, and and I didn't have a visa anymore in the UAE unless you have like a job or something like that. And at the time, I'd quit my job to start this startup. You needed a visa, and so I just came to the Netherlands. And first thing I did was try to find a place where I could establish myself. Find the equipment that I need, and try to do it here. Try to start my thing here. And so the first person I messaged was Vincent. Literally, the first person I messaged in the Netherlands was Vincent, and he's like, "Well, how do you like?" And I like I've been having this idea. How about we build something together? We try to figure out how to solve autonomous shipping. And so he came up with this idea. I can't remember if that was already at the email, but essentially, I remember arriving in Holland and the next day having a meeting with him, and from there, pretty much one thing led to another, and started Captain AI. And this was maybe I think 4 years ago or something like
Mm.
that. Wow.
So that story is kind of interesting because, or at least I'm not sure like the extent to which people normally come into this world from the software and kind of education that side of things versus someone who wants to build things. Like, is that something you've come across a lot?
It's a huge thing that occupies a lot of my thoughts, for sure, because everyone I'm working with is very academic. They've got a huge academic background, and I'm a little bit of an outlier in that sense. I always build things out of a need to solve a problem, and never formally. I would say, I never. I guess I just never thought of like one thing is that early on, I remember thinking that I generally, the things I learn at school are things that I fall out of love with, in a sense. And I was scared that I would fall out of love with making things. Although I did love the sciences and the physics, and I took way too many classes that were unnecessary, in those fields. Um, but uh, but yeah, I think in a sense I was a little bit scared of you know losing that passion I have for just taking things apart, or being very practical about it. What does it take to do this? And I think that's what I got really good at. Is like what I feel like is my skill now is like I get into like I'm good at addressing things I don't know anything about. So that's what happened with deep learning maybe 3 or 4 years ago. I started seeing the potentials because I was using OpenCV for prototyping a lot, and all of these more classical solutions. And then I started seeing a trend where you could do these detection solutions, and they weren't using OpenCV or anything like that, and they were just using like new ways of writing tensors, um, and I started seeing the solutions on that, and I'm like, okay, well, this really seems like this is how you're going to solve a lot of your problems. Soon. So I took some online courses and played around Jupyter notebooks type things, and try to skill up in that sense. And Yeah, I think a lot of the stuff that needs solving for like let's say radar detection or 3D bounding box detection, very deep learning based, makes deep learning makes a lot of sense for these things. Yeah.
How do you? Is there any transfer, or how do you see the transfer between like that world of building physical things and building, I don't know, cathedrals in your mind, software, let's say? Like, is there any like lessons you've brought to bear from your previous experience?
Yeah, I think there's still many lessons to learn, but that's indeed. I've discovered that I'm idealistic, and that I am very. I always assume like I'm very a little bit naive and assume great things can happen. And I don't really think it's. I don't want to get too philosophical here. Um, I don't really think it's necessarily a bad thing in my mind. I think when you're developing something, you tend to be biased towards the things that can go wrong. So, like, you tend to weigh out, okay, well, what are all the failure modes? How do we address them? But you don't really counterweigh all of the success modes and all of the potential avenues a solution can take. And so I think generally when someone makes a choice in the development process, they tend to average it out towards more like the negative side of things. And when you want to do something new and creative, you can't really base it on past experience. I don't know if I'm getting a little bit too vague here.
No,
Um,
makes sense.
you kind of have to because you're doing something new, you can't really just use history as a function to determine what the new thing is. There's some element of risk always going to be involved, and how you handle that risk becomes a craft or an art. I don't think there's a solution that you could just follow in the deployment or development of a new idea. There's a lot of lessons that you can learn. There's a lot of wisdom that can be bestowed by other people who've gone through the same process, but there is no formula in creating into something completely new. And I think until now, as far as I know, it's still an art. It's still something you have to run simulations in your mind of all the different scenarios, potential outcomes, the potential value. And it's a very difficult problem. It's really difficult, I think, but it's also really exciting. So yeah.
And yeah, I imagine a little bit later, maybe we'll talk a little about kind of iteration and how that fits into it, particularly in the world that you're working in. But yeah, perhaps now is a good place to talk about Captain AI. What it is you do. What's the problem you're solving?
Yeah. So there's what I tell people in the near term, and then there's like that long term vision that really is what drives everyone. I think, and I think the long term vision for everyone and the employees is to really do something that is exciting and new, and more in the domain of like actually making something navigate by itself. It's in a sense it's very profound because we take it for granted. We tend to walk around and do everything every day autonomously, but embodying that into something that moves around in the real world by itself is it's a challenge, but it's also a very profound challenge, I think. And also on top of that, to do that on water, which 70% of our planet is water. It's the vehicle for this planet. And to be able to add some level of autonomy, I think, in that would be great. In the future, I believe you could do a lot of really great things if the oceans were more accessible. Humans are not designed for the oceans. So I think if we can make it more accessible through simplifying the access to oceans by means of like maybe you want to survey certain types of parts of the oceans, so you can just send out your own eyes and ears and remotely see what's going on. I think there's a lot of things still to be discovered in the oceans. So from like a sensor side, a perceptive side, it's interesting, but also from a logistics standpoint. So what is it? I think 60% of the volume and 40% of the value of cargo is transported through seas. Don't quote me on that. It's something like that, where the masses of things that get transported is done overseas. And if we can offset a lot of the logistic problems onto oceans, it's a lot more efficient. Each cargo vessel has, hundreds of containers and a small staff to actually service that. So if we can offload all of that stuff that essentially gets transported by trucks nowadays or by cargo by airplanes, then that means that we have less congestion on the roads. It's probably even safer. I mean, I don't know how many car accidents are done by truckers that are driving excessive amounts of time. So I think it's just a better way to solve problems. And we discuss this a lot because the direct value proposition is kind of a hard one to address from that angle. But then we do have like the near term visions, that is what we're working on, which has more practical business senses in the short term. You know?
Right. Yeah. I was even as you were saying, solve the problem of like autonomous transport or autonomous travel or something you say. I was even wondering whether there's even a broader way of thinking about it. I don't know, at some point space travel is going to be more of a thing, right? And some kind of autonomous like travel is also going to be a thing there as well.
Yeah, I think our whole team we all love space and space travel. I don't know if it's because we grew up watching sci-fi movies or something like that, but we're definitely fans of it. And in principle, a lot of stuff we're working on should be able to be translatable into solving navigational problems in other domains, right?
Right.
And that's definitely something that
From hardware.
we think about. I bet
Yeah.
um, yeah.
I'm curious, like, so, we hear often about the the difficulties and the kind of the way it's been overestimated, the ease of solving the kind of autonomous driving thing has often been exaggerated or given these really like ambitious estimates. Like, what's the difference between the difficulties or the scenarios around autonomous driving and the maritime uses?
Yeah, I think the maritime is a bit slower moving in, industry wise. It's interesting. Maybe that's not the case because radar has predominantly been on vehicles way longer than it has been on cars, and there's been a lot more automation in the infrastructure side of things. But the maritime industry is very old, has very old standards, and I think what the issue is that because vessels require a huge investment to build,
Hmm.
they generally last for a very long time, and so you don't get that iteration cycle of like let's build a new vessel like you see with cars that they're building new cars every 10 years, right? And so most vessels that you see out there are already 30 years old. So you're talking more about the retrofits type of thing. So every 5 years, more or less, they get updated with new equipment, and so they want to modernize and they want to have new features and access to internet, better logistics, and so the game is a bit different in that sense. There's a lot of disadvantages and advantages in the sensor suite, and there's also kind of differences in the media. So like cars are traveling through a road, um, and that has a specific set of challenges, and we're traveling through water, which has a different set of challenges, and which are both good and bad. And But I think the problem that we have is very interesting. Um, One thing that I think we have that is like amazing is we have a huge source of historical data. Um, if so only It's only recently that you see Waymo, or I don't know if you're familiar with well these car companies, Waymo's, Tesla, Cruise, they're collecting data now, right? And so they have GPSs and a bunch of sensors on all the cars, and they're collecting that information, and then they're using that to kind of extract, predictions of routes, maybe help in situational awareness for detection, and do all these fancy detection solutions. But in the maritime industry, they've been collecting AIS, which is they've been collecting positional information of ships for a very long time. So they've been so a lot of the vessels, and it's actually required in the ports by law, have a GPS, and they need to broadcast that GPS as to be able to show their position to another vessel, and then visualize that on a screen. They also use it for vessel traffic management system, so VTS, where you would have someone who's a port operator would look at the vessels that come in, and they would have this software which would look at essentially AIS plotted on their screens, and then they can kind of get a good idea of where vessels are going. And that's a little bit more interesting because vessels are huge. You really want to keep track of them. You really don't want to have crashes with those. So there's been a bit bigger effort to kind of broadcast their position. And so we have access to this data, which we can use in a similar fashion. Only we have access of this data for years. Automotive industry only has it for a couple of years, but you could get, if you really wanted to, you could get like 10 years of dense historical AIS data from almost all over the world. And so at Captain AI, this is one of the directions that we've taken, which I think if you were really coming from first principles, kind of solving the autonomy problem, you don't just copy paste what other people do. You look at the resources available to you, and I think this resource is paramount to being able to understand the way vessels behave, to be able to suggest routes which vessels could take, and solve a lot of the problems you would need to in your autonomy stack.
Is that enough? Because I mean, basically, what you're talking about is just plotting like where a vessel is on the map. Like, presumably, you want the rest of the stuff as well, like the other sensors that you have. Maybe I'm misjudging like how you use this data.
Yeah, no, it's true. So AIS has a lot of failure points, primarily that the fact that a human needs to do the settings on it. So what AIS captures is GPS location, but it also tells you the dimensions of the ship. So you know how wide it is, how long it is. It tells you that, and then the interval of AIS is quite sparse. Maybe every few seconds, 3 4 seconds. I can't really remember, but it can be kind of you see them jump, and so another issue is that a lot of vessels just switch off their AIS. Like there are vessels that are navigating that don't even have AIS, and so what we're actually using from AIS is right now we're solving our route planner with it. So we're just creating a graph from all of the historical data. This is the direction and the way that vessels drove. This might be an interesting way for you to navigate to, and so we suggest that route. Um, but what we are actually doing also is we're using AIS as a template for pre-labeling, and this is where it gets really interesting with deep learning. Pre-labeling our radar data and pre-labeling our camera data. So what we do is we, in retrospect, so looking back, we collect the data, we interpolate that data, and then so at the moment that the radar was sweeping at that specific place, we know exactly where the box should fit around a blob. And so we pre-label all our radar data, which means that uh, when it comes down to adjusting those labels with human labelers, their workload is substantially smaller. So right now we're estimating that 50% of the work is actually being handled, in some cases even more, just through the pre-labeling process. And we're looking to extend this pre-labels into the camera domain too. So if you have a camera that is looking at a certain angle, you can actually project, or you can do the operations to be able to translate where you see a box, from a bird's eye view type of view to the view that a camera has, and that should be able to pre-label a lot of our data sets. And we're doing this as an alternative to using, let's say, LiDAR to label things and things like that. And this is, you would be able to generate way more data. Putting a LiDAR on vessels for data collection is not gonna be practical. And like what you hear from Andrej Karpathy and some other ML kind of experts that do this at scale, um, they tend to say invest in your pipeline. You're not going to get one data set and be done with it. It's something you're going to be doing throughout your company lifetime. And so we're really focused on these kind of more practical solutions. You use the data that's available to us to be able to generate models. And so that's the approach that we're taking right now.
So when I think of kind of how you would go about solving this, I imagine there's like a decent amount of reinforcement learning in there, maybe a bunch of simulation, maybe some synthetic data. Like, is there anything kind of big that's missing there?
We've touched on all those subjects. So there's kind of like we envision the solution to be somewhere at a times, and they'll actually include a lot of what you just mentioned. But I think for practical reasons and to be able to survive as a startup, you need to have short-term goals with a really realistic milestones. And I mean, like the ambitious future goal, I would imagine is some kind of multimodal sensor neural network that can predict things, and then you have some RL algorithm that kind of simulates these predictions and tries to they negotiate with each other to figure out what the optimal path should be and how to navigate and solve a lot of these problems. But that's very experimental. Like these kind of things are very, very experimental. So right now what we're doing is we're trying to validate the facets. We're taking let's say we want to know if we can detect really well objects using deep learning with radar, if we can do the same with camera. We try to optimize these models, once use classic techniques for fusing them. And once we have a level of maturity in that, and maybe some more resources, we'll look at doing something more fancy like that multimodal approach. Um, you mentioned RL or simulator training. So we used the simulator. We did a test because camera data is really difficult to get. And before we started implementing this labeling technique with AIS, we were trying to figure out how do we generate data. And of course, LiDAR is not practical and not scalable. So one approach was to use sorry, the simulator. So we have access to a high fidelity maritime simulator from a company called VStep. They're one of our investors, actually. The simulator is called Nautis, and we actually just programmed it so that we can see vessels from different orientations and teach a neural network to learn orientation. And so we generated, I think, about 70,000 synthetic data images with these labels, and got to like 63, 70% improvement, still state of the art. Um, and we're hoping that with this real data that we'll generate, we're really going to get to the type of performance you see with bounding box detection, like really nice. Yeah.
Can you run the simulator at like non real time speeds or like yeah
Yeah.
accelerated?
So yeah, it's because if you're doing RL, we looked at RL and trying to do on policy training in the sim. Um, and so we can manage to speed it up 10x with the physics, but then the physics starts breaking down a bit. So we actually looked into lower fidelity simulations and things like that, and then looked at lens networks. Can we transfer that lower fidelity into a higher fidelity, train on the higher fidelity, and translate it into the real world? And that was something we looked into a few years ago. But I think that RL, in terms of learning on policy in a sim, is not the way to go. Not anymore. I think you see a lot of things that they kind of simulate. You can create a simulator without even having to program, all of the visuals in it, and to do all these rule based,
Yeah,
because that's a lot of work. But
right.
with deep learning, you can create these prediction models and say, okay, well, if I saw this boat here and I saw that boat there, the boat will be over there, and you can capture these interactions. So we've looked at doing prediction models, just using positional data, and we have access to a little bit higher fidelity than just AIS. So we have AIS fused with radar, and so we can track the positions, create, let's say, a neural network that predicts that motion. And what you can imagine is that you could now do on policy training with your predictions. And so you have a simulator which is learned on the real world that can kind of tell you this is how things will go. And then you can create an on policy training with RL using that type of simulator. And I think that flavor of approach is probably more realistic. Yeah.
I'm curious. So, like, obviously, I mean, reinforcement learning is no longer kind of cutting edge or something particularly new. Like, lots of people have some exposure to it at least, but like, where's the intersection between kind of the ongoing research which is being done in this world and what you're busy with?
Yeah. So I think if you there's solutions out there that are phenomenal. I'm really getting excited, especially this year. Like what we see with GPT-3 that really shows like the prediction capabilities. Just like what happens if you just predict, and the fact that you can do more than just predict. You find all of these alternate use cases for it, which is really interesting to explore. Um, I also think that with Nerf, I don't know if you followed with Nerf. So Nerf is a way to visualize using neural networks. So back in the day, we used to do something called SLAM or something. We would, it would be called photogrammetry. You take a lot of pictures, and it's still photogrammetry to a certain extent. Take a lot of pictures of an area, and then you use properties like features of that property of those pictures and knowledge of the positions to be able to reconstruct a 3D model of it. But now with Nerf, they've shown that you can rephrase that problem into instead of trying to do that, why don't we just teach the neural network to render at a given location? And now you give the input data of their positions, and you essentially use radiant fields, I believe, to render what a view would look like. So now you're like that changes. This is like fundamental paradigm shift in the way that you would actually visualize things. Now you don't need ray tracing or these engines. Like things are, there's another way to do this now, and so that's those kind of things are more on the cutting edge side, and I feel like that's the direction we should go into. But we're also a startup in the maritime industry, which is a slow moving industry. So you have these contrasts where which technologies are really promising, very experimental, but it's kind of the possibilities. And then you have to bring it down to the practical cases. Well, that these models, like bounding box detection type of models, single shot detectors or whatever, they're kind of more practical. They've been really well vetted, huge data sets for them. You're going to get a solution out of that. And so it's a luxury to be able to experiment in a more sophisticated domain. And I really hope that as we grow as a company, we get access to spending more time in researching those fields, because I think the returns will be huge. I think it's just a very exciting time to really explore those technologies, and I'm sure there's going to be so much value, business value in them too. Yeah.
Um, if we shift a little bit towards thinking about like just how I guess you deploy what you're doing on kind of out in the real world, like how does that deployment and kind of real world piece like shift about how you go about things?
Yeah. So in the deployment, that's something we're currently like facing. So I think it's very straightforward if you kind of deploy something in the form of a Docker container, right? Internally, it kind of makes sense. We've been building a lot of the things separately. And so, like, if you're, let's say, working on radar detection and you want to improve your model, you want to keep iterating in that. But radar doesn't work by itself. It has to interface with different modules ultimately to give a good perception sense for the autopilot. And so we've been using Docker to solve that problem of that modularity. And with that comes the versioning. And so you get different solutions like Torch Serve or TensorFlow serving, those kind of solutions that you essentially just pull a container which is ready for serving a model, and you just modify the infrastructure so that it can handle the type of model that you're trying to do inferencing on, and then all of a sudden you can already do inferencing from multiple different computers if you want, and it'll handle that really nicely. It'll make use of the hardware nicely. So that's essentially how we do the deployment part of it. Of course, you've got solutions that deploy containers remotely, which is interesting too. And then, but really, all the way to that point, it's probably like that's just like the icing on the cake, right? That's like the tip of the iceberg. You still have to the whole data acquisition pipeline, labeling pipeline, model validation. There's so much stuff you have to do before you can even deploy this model. And so we've been doing it probably the hard way, because we've been doing this more or less without the existence of a lot of this what is available nowadays. Yeah.
Mm-hmm. Yeah, I'm curious. Like, I mean, as much as you can share, like, what does that stack look like? What does the workflow look like, kind of on that kind of end to end scale?
Yeah. So the goal is that what you're saying, and like complete end to end. So data acquisition to data model training, validation, and then deployment. And I think like the way we envision it is that in the future you'll probably have a tight cycle on these things where you're acquiring data from the vessels, you're training it, you're updating it for different locations. Things change, so you want to be robust to that. And so, with that in mind, we have been building, let's say, rigs, ways to collect data on vessels. Right now, we store them on hard drives because the amount of data that we collect is impractical to send. It's not really practical to send over. Like, I can just drive over to the vessel, grab a terabyte of hard drive, which would take
Right.
quite a while to just transfer. So we just and hard drives are pretty cheap nowadays, so you can just put a couple of terabytes in it and collect data. You also want to be smart about how you collect that data, because if you have terabytes of data, you have to comb through all that data. So maybe you want to be smart about when you're collecting it. So we have like stuff set in place like that say, okay, only collect when the vessel is navigating. So if we know that the boat is navigating, then only we collect. We also do collection bursts, so we don't collect the whole time. We collect just in little bursts, and so even though we are not going to use a full sequence of things yet, we are planning for in the future. There's probably going to be more sequential type of models that we want to cater. but and then we'll have that data sets there. Um, that gets processed in house with a bunch of and I'm not the one who did this. You should probably talk to my colleague about this because he's a bit more involved in that. But what happens is that we just run scripts that processes the data, converts the data into the formats that we need for the pre-labeling, does the pre-labeling guesses. So like I mentioned, we try to pre-label the data using AIS quite a bit, and then get it to a point where we actually have some software that we could get third or to get other guys like interns or maybe students to label. And so we're also that also requires quite an effort to figure out, okay, what labeling services do you use? We've looked at Labelbox. We've used Mechanical Turk. We've used what's it called? Turn 8, I think it was called. Now they're called Crowdflower, I think. And so Scale AI seems to be one of the newer ones with a lot of the functionality where you can actually translate between 3D space and 2D space. But a lot of their features that would be interesting for us are still kind of in beta. So we're still waiting on that. And so because nothing really checked the boxes, we've been building a lot of small pieces that were custom to our needs. Um, and so yeah, we're still figuring it out in a sense, but we've got a clear idea of of how this should fit together. Um, and we've already got a few models that we have deployed, let's say. So if a client wants to see how good our radar detector is, we have a model that you can access online. You just put an image in it and it'll return a bounding box, and you can do your own validation and quality assessment on it. You know,
And what would you say are the kind of the biggest challenges there in terms of that that whole process? And I guess like yeah, the barriers that are preventing you from reaching like that dream of the kind of the fully automated version of that, aside from you having to like drive to the boat and pick up the hard drives.
yeah. I don't want to be facetious to use that word correctly, but it literally is the unknown unknowns. It's like the things that you don't account for. And I think that occupies time, which never gets scheduled. Because how do you schedule that? It's like, and so what ends up happening is like you get you've got to deal with things that come up, and um, I think well actually something that is more addressable would be like our models are generally not off the shelf. We tweak our models, and that makes it really hard because all of the pipelines that you see for deployment are generally designed for a specific model in mind. And I think that's where TorchServe is a bit nicer. They've got these. I think you can customize that a little bit. But then again, you got to use you know to assess the requirements, the hardware requirements. Uh, that's also going to be a point. Right now, we just overkill. We're just like, and I think it's okay. So because generally the clients, for them, it's in proportion to a lot of the different things. It's not a concern, and they can afford like a nice GPU. So we just throw in a good GPU, make sure that everything works well. But I think at some point, once we mature, we'd want to also be more considerate of the hardware requirements, things like that. Um, yeah, but actually, it's a problem that I think um, might also be lack of, of, of staff. I mean, we're looking to hire right now, deep learning guys. Uh, you know, and I think to find someone who can do deep learning for us, as a startup, I know they can get really good salaries at other places. Uh, but we offer an opportunity to kind of do things um, at the edge, right? To be part of the team, be part of the startup, and I think that's it really exciting. So we're actively looking for people to help us in that sense, and that should also help us address some of the unknown unknowns that we're going to come across. Um, yeah, I think experimentation time that's huge. 1B is awesome, because you can just run different sweeps of different parameters, which is huge. I think in figuring out a lot of the model performance comes from parameter tuning. You know,
Mhm.
and that's also time consuming. Like not only do you have to figure out the model and which data works well, you also have to figure out how what parameters it is.
Right.
I think it's just a lot of work. Prototypes are really easy. You just have a small data set, you run it on your laptop, and you get it out. But it's a lot of work if you're doing this at production scale, right? Because you have to do a lot of validation, a lot of checking. Yeah.
Does that? I mean, maybe that goes to like the pace at which you can iterate as well, and like the systems you have to support a faster pace. Like if you could optimize that, that would help you.
Yeah. Like I would definitely want to try transformers with everything, right? I think it's got a hype right now, and from what I understand, is that transformers tend to be really performant because of reasons, but it's also very sensitive to tuning. So it's risky. LSTMs work really nice for a lot of these things. Um, so like we would definitely do a transformers for some of the problems if if it wasn't too risky.
Right.
I think it's and the risk only gets mitigated by trying it. Like you just need to do it and try it and see if it works. And so yeah, so we're resource constrained in that sense.
Yeah.
Yeah.
Yeah, and I guess you need resources and time and all of this to be able to like just play around with things and experiment. Yeah.
Yeah. I wish you could outsource that. You probably could, but the thing is, you also want to have that skill in house, right? You want to when you do these kind of things, you want the people to be aware of the
Yeah.
problem that they're solving uh, in a very intimate way, I would say. Yeah.
Right. It's not
Yeah.
just you can just I don't know release a bunch of data or whatever on Kaggle and like have a competition to see like
We
what.
thought about that. That would be a great way to, I think, do skill acquisition. Like, just throw it out there. Some people are going to come up with some really nice ways to solve this problem, and those people deserve a job for sure.
Right.
Uh, yeah.
um, how do you feel about like the tooling maturity? And maybe you're not the person necessarily to ask specifically about this, but do you do you feel like we're at a place where a lot of this stuff is mature and kind of robust in a way, or yeah, other things
Yeah.
that
So I kind of stopped doing so much deep learning in the past year. I follow up on it, but when I got started, I played a lot with TensorFlow.
mm,
And like you would work with TensorFlow, and 1 year later they had 2.0, and it was completely different.
rich. Yeah,
Yeah. And so they built backward support for a lot of the models because at that time, by the time 2.0 released, everyone had built such a foundation, and so many models were developed on 1.0 that they had to kind of really make it easy for you to still have the 1.0 features. Um, so I think it's growing really, really fast. It's crazy, but I think we're settling now. I personally, for my side experiments, I use Keras just because I don't have time. It's just a lot easier. Um, and so I find that if you can put it at such a high level where you're just specifying layers, then there's some kind of it's kind of stabilizing and coalescing into some standard formats. Um, but there's so much out there nowadays. Everyone's doing their own kind of tensor operations and have their own formats, and you're coming up now with things called Onyx, like these cross-platform solutions, and so I think you're starting to see a little bit more maturity there. So things are coalescing now. I think it was kind of like an explosion, and a whole bunch of different things were developed. And like you would use a language which had the model. Like, at least that was me. Like I would be like, okay, if this is implemented in PyTorch or something, I'll clone that repo, play around with it, see how that works. Um, because you don't want to re-implement that in a different language. But now it's getting so a little bit more straightforward. I think. Yeah. Well, how do you feel about that? The maturity of the
I
languages.
mean, I think I feel like in the kind of the model development space and iterating over that, like things are seem a little bit more stable and mature. And now we have PyTorch and all of these kinds of things, and um, as well as kind of lower level solutions, and Jax is out there and all of these kinds of things. But the bigger picture, I feel, is definitely a bit more wild west, and there's definitely a lot more kind of consolidation that needs to happen there, or just better abstractions need to be created. And obviously, it's difficult because we're kind of simultaneously trying to create the abstractions while we figure out like the problem space at the same time. So obviously, it's going to continue to change for a few years.
Yeah, I think
Um,
that's a really good way of putting it. That we're approaching the problem space. We're still trying to find, well, we're trying to create the abstractions, and so that's actually a recipe for a disaster a bit. I think. Yeah.
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 But are you mainly kind of Python based stuff, or do you go lower level? Yeah, give
Yeah, I think well, for deep learning, definitely Python. I don't think I think is it true that Torch PyTorch is dropping support for other languages now? I think I don't know. I don't know if that's probably not true, but I think a lot of people aren't even thinking about all the other ways to do it, and they're just doing it in Python, especially now because a lot of the students that they come into school for AI, and so the language that they get introduced to is Python. And so by the time they graduate, Python is their language and how they've learned things. And so I think that C++ skills might be lacking because and being more reserved for performance.
right.
Where like if you wanted to create the binaries that are called by these higher level languages, you'd write it in C++, or I think Rust is now becoming the more popular one. Um, so yeah, definitely. I think Python is definitely deep learning, but then when you're coming to like a lot of the other problems that we're facing, like you want to reduce latency, so you need to send camera footage, and when you're controlling a vessel or you want to modify it, you don't want to have that delay.
Mhm.
Um, and so we're looking at frameworks like GStreamer, for example. GStreamer is a really efficient framework for media data,
Mhm.
and things like that. So we do have a few different languages that are more catered to the performance, but I think you'd be looking at CUDA if you really want to get down to the crux of performance, and it might be more interesting in the hardware sense. So if you're trying to
Mhm.
reduce cost on your hardware, you want to kind of exceed the performance of your model. Um, but at the stage we're at, I think with Nvidia, I don't know if you've had a chance to explore some of their embedded or deployment solutions. They have like Nvidia Agx, which Jetson Agx, which is kind of like a Raspberry Pi, but for with a GPU. And what's nice about it is that they have a lot of the uh, accelerations like TensorRT already kind of built for it, and so it makes it very accessible for you to run your models using these hardware accelerations. But outside of that, I don't think we really custom do anything. We just use what's somewhat easily available. Again, we're an ambitious
Sure.
startup doing way too much and looking for people to help definitely.
Simple solutions.
But we
Yeah.
have to be smart about where we put our efforts.
Yeah, I thought maybe you were going to say something about, I don't know, Julia or something, but yeah, it's sort of
Yeah, yeah,
like stick with what's reliable and has a big ecosystem as well.
yeah. I personally don't have much experience with Julia. I read a few blog posts I think about it, but do you recommend Julia for these things?
I've only dabbled a little bit, but I mean, people who are working in the Julia space seem super enthusiastic about it, but
Yeah,
who knows?
yeah, yeah,
Yeah. Um, in terms of kind of just like, so you've got a product or a service or something which is out in the world and is interacting with people and things that can crash into each other. Like, I'm curious how you think about like risk and danger and like all of
yeah,
these kinds of things. Like, you can give people the wrong information, or
yeah.
maybe there's also, I'm sure there's some kind of legal framework in which you have to operate as well. Like,
Yeah,
how do
yeah.
you balance all of these things?
Oh yeah, this it's a complete dance. I mean, obviously, you can only sail autonomously if you're allowed to sail autonomously, and it's also safety is an issue. If you crash your boat, it's not a good thing. Um, and so we have these kind of discussions about, you know, like how do we, how do we make sure that we can iterate fast and maintain a safe working environment. And these are challenges we have to address. These are things that it's really nice to iterate quickly, but when things can go really terribly wrong, that's not a good idea. And so we're practical. We try to use the sim. We do a
Mhm.
lot of the testing in our simulator. So the simulator we have actually has motion models and physics programmed in, and so a lot of that like kind of stability testing can be done in the sim. And then, of course, we have captains that literally hold the steer and override procedures that they can just take control if they ever feel the need that something is not right, and all of that needs to be in place. But then I think also from a moral standpoint, I was arguing that you kind of have to solve autonomy um, to reduce the amount of crashes, because if we can like offload how many people are driving in those trucks that have crazy hours on this more efficient mode of transportation by making it more frictionless and better and improving the logistics on it, then essentially you are saving lives. So you can uh, you got to see the good side of it too. Like I said, I feel like a lot of people tend to overweigh the pessimistic point of view and tend to be wrong because they bias towards that direction. So they're like, oh yeah, what if a whale? I've literally had this question. What if a whale breaches on your boat and something like that and destroys things and people? You get all you can. There's so many things you can think of that can go wrong, but then you also have to be fair and think of all of the things that can go right. And I think that technology has only made it so that we can sustain such a big population on this planet, and has only done good things. Of course, you have the nuclear bomb and all these bad things, but I don't know. I could argue um, a positive use case on all the technologies we have.
Mm.
I think people take that for granted. I really think people take it once the technology is part of your everyday life. You tend to forget how things used to
That
be.
was your baseline. Yeah.
Yeah, and so we're living like kings in this time and age because of technology. Yeah.
Is there I'm trying to think of like what the equivalent would be. I guess it's maybe not the same. Like, is there a maritime equivalent of the trolley problem in your world? Like,
Yeah. Um, well, yeah, the trolley problem could be like applied to the maritime domain. Yeah.
you don't have as much. It's less, or it's rarer that you have so many like boats all in the same place.
Well, no, you should see some videos. I think every 5 years, 4 years, Amsterdam, they've got these boat events, and it's just
Sure.
ridiculous.
Okay, there's yeah.
Yeah. So in fact, I think the next one's in 4 years or 3 years, and we wanted to sign up because we're like, okay, at that time we're going to sail this
Right.
crazy situation, and our software is going to be able to do it. But yeah, so I think trolley problem is like a philosophical problem. I think the way I ration it or reason it is, uh, yeah, but the way I reason it is that what we're doing is essentially a more sophisticated form of like a conveyor belt, right? Um, in the factory, you've got conveyor belts that are transporting one thing to another. Um, and so what we're doing is instead of having that very simple environment with that just you push a belt over and there's not much noise in that situation, we're pushing a box or a vehicle across the water. And so what happens is that your perception of your position is a little bit more noisy. Your control has to be more sophisticated, but in principle, it's not any different. And so that's how I see it. When you're talking about the trolley problem, you're really trying to say like, okay, uh, it's like, is it better to? It's just should the robot decide whether to destroy this, five bad people versus one good person, or things like that. Um, and I'm sure that there's going to be a lot of interesting like discussions in that space once the maturity of this technology is at that point. But to be frank with you, I don't even think AI as it is right now has the ability to conceive of ideas, right? Like you need to prompt GPT-3. I mean, it's great, all of the stuff that comes out of it, but the human still prompts it. And till you have some kind of like self-evolving, self-prompting kind of system, which might happen soon or not, I don't think that those problems apply. It's a mechanical problem until like there's this level of choice that a machine can make. So let's address that once that's actually the case.
Yeah. So we usually end with a couple of kind of quicker questions. You can take it in kind of whatever direction you want. So the first one would be, what would be a kind of a quick win that someone can add to their systems to make putting models out in production more robust?
Yeah, I want to. Yeah, so I think being very clear about your metrics, which the software is doing really well. Um, like, yeah, it's hard because the stuff that really leads to the improvement is like trying to be really good about your assumptions, right? Uh, yeah, so try to make sure that uh, that your assumptions are really clear, or that you're really clear about how this works. For example, like if you were to like we're collecting radar data in a single area, and then we're trying to think of, okay, well, how diverse does this data set get to be? And so one way to assess that is to have a data set of, like, it's not just reserving a section of your data and then using that as your test set, but literally going the extra mile and saying, how about we put in a data set of just a completely different place, right? And so it's not just following the rule, 20% is testing, is like to actually rationalize what does it mean to test, and to check its uh, its adaptability to different situations. But other than that, I can't really give you that much of an insight in terms of the more practical technologies. I'm not really the one doing that. Yeah.
And what would you've at least spoken a little bit about this earlier, like what would be kind of one part of putting models into production that you feel like needs to be given more attention by tool makers in the space? Like what's the thing you're missing?
I think most people would always kind of directly go towards some form of automation. Like, let's automate the procedure more, right? Um, but I don't know if that's always going to be good, because, like you said, we're still trying to solve the problem space. So I think this level of improvement uh, might be like that over engineering, maybe. Um, yeah. So that's not really an answer. Um, uh, I
Well, I
think,
guess what you're saying, I
yeah,
guess what you're saying is like that the we don't currently have like good tools to deal with this stuff, and so that's what we need.
yeah. So let's say like there's this like cure all like transformer type of vision. I think everyone's just adapting transformers to everything. And if that's the case, then maybe building a tool that lets you uh, try a type of model like that over different, if it really is that generalizable, then the problem becomes more of a tuning thing and making that easy, right?
Mhm.
So maybe there's a whole deployment solution that could just specialize on one very generic type of model. Uh, yeah, but other than that, I don't think I got a good answer for you.
Thank you very much for coming on. Like it was super interesting. We definitely don't speak to too many people who are like deploying things out in the world so much. It's often a lot more software based. So yeah, it's definitely
Yeah, yeah,
interesting.
yeah. So this is our first year really deploying things. I could probably speak to non-deep learning kind of solutions, and there's a lot of REST API type of solutions, and that's great. That's awesome. It's
Yeah.
very simple. If you wanted if you're using images, gRPC. But it's really nice to have something that is being served online, and to let people use it. You know, yeah, it gives a lot of validation, at least if you're. So yeah, I think the space we're addressing is also a little bit more esoteric in the sense that it's hardware. It's really like also stuff that has to work on the boat. I think a lot of these solutions right now are very accessible for online applications.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.